Okay, good afternoon, class. So at this point, you guys have done exercise 9.2, number 1, correct?
Yes.
So in this video, we're going to only look at number 1, and then we're going to leave number 2 for tomorrow, okay? Let's copy this. So exercise 9.2 is on page 280. 283. Okay, so here we are told that O is the center of the circle in each diagram. So O is the center of the circle in each diagram. Determine the value of the variables in each case. Show all your working and give a reason for each step. I'm going to make this a bit smaller. So it is exercise 9.2, number 1. Okay? Right, so what's the value of A, people? A is angle at center, is twice angle at circumference. So A is equal to 2 times 32, which is 64. Angle at center equal to 2 times angle at circumference. You all okay with that?
Yes.
Let's look at B. I'm going to calculate B. You see this arc here? That arc is subtending an angle at the center. That same arc is subtending an angle at circumference. Can you see that, people? So angle B has to be half of that, not so. So B is equal to half times 68, which is 34. Reason? Angle at center equal to 2 times angle at circumference. Okay. Right. Let's look at C. So there's your angle at center. And C, of course, the angle at circumference then. Can you see that, people? So C is equal to half times 110. Okay? Which is 55. Reason? Angle at center is equal to 2 times angle at circumference. Okay, so there's now 55 here. I'm going to calculate D. Same. Why? Because we have this angle at center is twice the angle at circumference as well. Okay. So D is also 55. Because the angle at center is equal to 2 times angle at circumference. Was there any confusion here? Is Lala, you okay? Right. People, D. Follow DD. Right. E, how will you calculate E? Angle at center is twice. You see this arc here? Is subtending the angle at the center and is subtending the angle at circumference. So angle E is going to be 2 multiplied by 100, which is 1. Why? Angle at center is equal to 2 times angle at. Okay. There's 200. Let's look at E. Okay, there's a lot in E, no? So let's try and do it alphabetically. You got E, then F. Okay. So here, angle at center is going to be twice the angle at circumference. Not so. So is f going to be larger or smaller than 120? Larger. No? Just remember, the angle at the center is the larger one. So we say f is equal to 2 times 120, which is 240. Why? Angle at center is equal to 2 times angle at circumference. That's 240 now, not so? G. How are you going to calculate G? Devolution, not so? Okay. So G is equal to 360 minus 240, which is 120. Why? Devolution. Okay. So now what do we say? H? Okay, so half 120. Why? Angle at center is twice angle at circumference. So H is going to be half 120, which is 60. Angle at center is equal to 2 times angle at circumference. Okay. They have calculated all the angles required. Is there any confusion at this point? Easy, no? Yes, I hope it's going to stay so easy. Let's look at F. What's wrong? What's wrong? Okay. F. How do you calculate F? Where are we now? E, F, G, H, I, J. Right. How are you going to calculate J? With J. J and K is the same, not so? But here's also angle at center is twice angle at circumference. Can you see it's the same arc? Crazy, no? But you guys see it? Huh? Some of you saw it, yes? You are saying clearly now you saw it already. Is that okay? Not everybody's so fortunate. So you got angle at center is twice angle at circumference. So J is going to be half times 94. Half of 94, which is 47. Why? Angle at center equals 2 times angle at circumference. So that's 47. Okay. Now what? K is 47. Why is K 47 degrees? Equal radii, not so. So it's angles, opposite, equal sides, and it's the radius. Looking at L. Yes. No. Because I'm using two theorems. Using two theorems. But this is also equal, not so. So what's the size of this angle? The same as this. This is L. Okay, so what can we say now? L plus L is 2L plus 94 equals 180. Why? We use three things here. What did we use? Sum of triangles. We use angles opposite equal sides. And we use the fact that it's a radius. Radii. Okay. Take that over the equal sign. So 2L is equal to 180 minus 94. 180. 86. And 86 divided by 2? 43. Okay. You guys understand? Yes? The J. Okay, let's go again with J. You look here. You see angle at center? Now this arc here is subtending that angle at circumference. Can you see that? So that's how we say that J is equal to, remember this is the smaller angle, so you must divide by 2 here. So J is equal to half of 94. Angle at center is twice angle at circumference. Okay, any other confusion? Just remember, just look here. If you look at the circle here, see, if you look at this, that's your center, not so. Now, if this is obtaining that angle, that's easy to see. Not so. So that is x and that's going to be 2x. Not so. However, if I take that same arc and I subtend the angle here, that is x and that is 2x. Can you see that? It's the same arc. And it will be the same if I take that point there. It goes through there. That is still going to be x and 2x. You see that? So that's the concept we're applying. Okay, let's look at G. G. People, M is going to be 100. Y. Angle at center equals 2 times angle at circumference. So what's the size of this angle? N. Y? Radius. But you see there's no markings there. Not so, I can't first say that the angle B1 is equal to N and then work it out. No. There's no markings. So I would also don't put my own markings in. What I do is I say, okay, 100 plus 2n or n plus n equals 180. I'm using 3 theorems there. What are they? Sum of triangles, angles opposite equal sides, and the fact that it's your radius. Of course, if you leave one of that out, you're going to lose the reason mark. Okay. So 180 minus 100 is 80. Divided by 2 is 40. Okay. Is there any confusion there? No. Am I moving too fast? No. Okay. Look at H. See, that's what happens when you become lazy. Man. You have to take it apart. But anyway, let's look at H. Right. So where can we start? P. P is going to be 110. Why is P 110? Angle at center is twice angle at circumference. Right. So 110. Q. Revolution. So Q is going to be 360 minus 220. Revolution. Which is 140. R. Angle at center is 2 times angle at circumference. Can you see that, people? So R is equal to 70. Angle at center is equal to 2 times angle at circumference. It's just becoming easier and easier, not so? I. Angle at center is equal to 2 times angle at circumference. So what's the angle at center? 3x minus 62 is equal to 2x. The reason here is angle at center equals 2 times angle at circumference. So you get 2x over 62 over, so 3x minus 2x. So x equal to 62 degrees. Any confusion there? Right? J? So if you're looking at, we know that the angle at center is going to be 42. So O is 42. Why? Alternate. Do I have letters on those sides? Lens? No. So no parallel lines, no naming on. Are they? What are they? P, R, Q, P, R, O, Q. Okay, and the textbook I had, it wasn't there. So in other words, that means to say, with PR parallel to OQ. So that is 42 here. Then angle P is equal to? Nope. This way now, the alternate angles. So angle P is equal to 1. Angle P is equal to 1. Okay? Angle P is equal to y. Reason? Alternate angles with PR being parallel to OQ. Now what? Angle at center is twice angle at circumference. Can you see that? So y is equal to a half of 42. That is angle at center is equal to 2 times angle at. Give me an answer. Okay. Is there any confusion there? No. So that basically, yes? What? Sorry? Because remember, angle at center, you see this is an arc PQ. That arc is subtending an angle at center. That same arc is subtending that angle at center and circumference. So angle at the center is double the angle at circumference. Okay? So you just multiply it. If the y was here and the 42 was here, what would I have done? Times it by 2. Why? Because the one in the middle is going to be the larger angle. Okay? Anything else? Okay, so with that, you should be able to complete number 2, 3 and 4 of exercise 9.2.